Hey everyone, welcome to this video on differentiation. Differentiation can seem intimidating at first, but trust me, it's a lot easier than it looks. By the end of this video, you'll be able to differentiate a wide range of functions with confidence. So grab a notebook, a pencil, and let's get started. So what exactly is differentiation? In simple terms, it's all about finding the rate of change of a function. Imagine you're driving a car and you want to know your speed at any given moment. In calculus, we call this rate of change the derivative. It tells us how much the output of a function changes when we make a tiny change to its input. Knowing the derivative of a function has tons of applications in physics, engineering, economics, and even in fields like machine learning. For instance, if we know the position of an object as a function of time, its derivative gives us its velocity. Now that we have an intuitive understanding of what differentiation is, let's dive into the formal definition of a derivative. The derivative of a function f(x) at a point x is denoted as f(x) or df dx. It's defined as the limit of the difference quotient as h approaches 0. The difference quotient is simply the slope of the second line passing through 2 points on the graph of fx. As we make h smaller and smaller, the second line gets closer to the tangent line at the point x, fx. The derivative then is the slope of this tangent line. In practice, we don't always have to use this definition directly to find derivatives. Instead, we can use some handy rules and shortcuts. Now, let's talk about the fun part, the rules of differentiation. These rules are like shortcuts that make finding derivatives a breeze. The first rule is the power rule. If fx equals sine x circumflex n, then fx equals sine nx circumflex n1. For example, the derivative of x squared is 2x, and the derivative of x cubed is 3x squared. Next, we have the constant rule. The derivative of any constant is 0. The constant multiple rule tells us that if we have a constant multiplied by a function, we can simply take the derivative of the function and multiply it by the constant. For example, the derivative of 3x squared is 3 times the derivative of x squared, which is 6x. The sum and difference rules state that the derivative of a sum or difference of functions is equal to the sum or difference of their derivatives. So if we have fx equals sine gx plus hxx, then fx equals sine gx plus hs. Remember, practice makes perfect. The more you practice applying these rules, the more comfortable you'll become with differentiation. Alright, let's put these rules into action and differentiate some simple functions. Suppose we have the function fx equals sine x cubed plus 2x squared, 5. Using the power rule and the sum and difference rules, we can find the derivative step by step. The derivative of x cubed is 3x squared. The derivative of 2x squared is 4x. Using the constant multiple rule and the power rule, the derivative of minus 5 is 0 using the constant rule. Therefore, the derivative of the entire function is fx equals sine 3 squared plus 4x. As you can see, differentiating simple functions is all about applying the rules we learned in the previous chapter. Now let's move on to some slightly more complex functions involving products and quotients. The product rule states that the derivative of a product of 2 functions is equal to the first function times the derivative of the second function plus the second function times the derivative of the first function. In mathematical notation, if fx equals sine uxvx, then fx equals sine uxxvx plus vx ux. For example, let's say we want to find the derivative of fx equals sine x squared plus 1, 3x2. We can let ux equals sine x squared plus 1 and vx equals sine 3x2. Then ux equals sine 2x and vx equals sine 3. Applying the product rule, we get fx equals sine x squared plus 1, 3 plus 3x2, 2x. Simplifying this expression gives us the derivative of the function. Now let's explore one of the most powerful rules in calculus, the chain rule. This rule is essential for differentiating composite functions, which are functions within functions. Imagine you have a function gex inside another function fx, such that you have fggx. The chain rule tells us how to find the derivative of this composite function. It states that the derivative of a composite function is equal to the derivative of the outer function, evaluated at the inner function, times the derivative of the inner function. In mathematical notation, if I equal sine FU and you equal sine gx, then di slash dex equals sine d do asterisk dou ds. Suppose we have fx equals sine sin x squared. Here the outer function is sin u, and the inner function is u equals sine x squared. The derivative of the outer function sin u is cos u. The derivative of the inner function u equals sine x squared is 2x. Applying the chain rule, we get fx equals sine cos x squared asterisk 2x. Alright, it's time to put all the rules we've learned into practice with some more examples. The key to mastering differentiation is practice, practice, practice. Let's start with a function that involves a combination of rules. fx equals sine 2x cubed plus 1 circumflex 4. Here we need to use the chain rule. The outer function is u circumflex 4 and the inner function is u equals sine 2x cubed plus 1. The derivative of the outer function u circumflex 4 is 4u cubed. The derivative of the inner function uu equals sine 2x cubed plus 1 is 6x squared. Applying the chain rule, we get fx equals sine 4 2x cubed plus 1 cubed asterisk 6x squared. Substituting u equals sine 2x cubed plus 1 back into the equation, we get fx equals sine 4 to 2x cubed plus 1 cubed asterisk 6x squared. Remember, the more you practice, the more comfortable you'll become with identifying the different rules and applying them correctly. It's always a good idea to double-check your work, especially when you're dealing with something as important as derivatives. One way is to use a derivative calculator. There are many free online calculators that can find derivatives for you. Simply enter the function and the calculator will provide you with the derivative. However, it's important to note that relying solely on calculators is not ideal. Another way to verify your results is to differentiate your answer. If you differentiate your derivative, you should get back the original function or a simplified version of it. If your answers don't match up, don't worry. It simply means you need to go back and review your work. Learning differentiation doesn't have to be a solitary journey. There are tons of fantastic resources available to help you along the way. Textbooks provide a structured approach to learning calculus with clear explanations, examples, and practice problems. Online resources like Khan Academy offer comprehensive calculus courses that cover differentiation in depth. Websites like Wolfram Alpha and Symbolab provide step-by-step solutions to derivative problems. If you prefer a more visual learning style, there are plenty of educational videos available on YouTube and other platforms. Remember, the more resources you utilize, the better equipped you'll be to tackle even the most challenging differentiation problems. As with any new skill, mastering differentiation takes time and effort. The key is to practice consistently and to be patient with yourself. Start by working through the examples in your textbook or online resources. Once you feel comfortable with those, try tackling some practice problems on your own. Don't be afraid to make mistakes. Mistakes are valuable learning opportunities. With enough practice, you'll be able to differentiate functions with ease. Congratulations on making it to the end of this differentiation crash course. You've learned the fundamental concepts, the essential rules, and some helpful tips for success. Remember, differentiation is a powerful tool that can be used to solve a wide range of problems in various fields. Don't forget to like this video, subscribe to the channel for more educational content, and hit the bell icon to stay updated on new uploads. Keep practicing and you'll master differentiation in no time.